Now let's consider example 1. So I want to write down the trial solutions for the method of undetermined coefficients. So the first column of the table give you the form of G of t, or the forcing term, and on the right hand side you're going to make the guess for the particular solutions. So in the case of if you have only a constant function, then the form can be y sub p equal to some constant only. If g of t equal to a linear function, then the guessing solutions, or the trial solutions, has the form of a times x plus b. If let's say you have a quadratic functions, then the guessing solutions, or the trial solutions, can be ax squared plus bx plus c. Right? So given a quadratic functions, then when you make a guess or the trial solutions, you have to write out the entire polynomial functions of degree 2. Now for psi function psi of 4x, the trial solution is a times cosine of 4x plus b times psi of 4x. Should be a linear combination of both psi function and cosine function. Now this goes the same for cosine of 4x. A times cosine of 4x plus b times psi of 4x. When you have an exponential functions, then the guess should be y sub p equal to a times e to the 5x. The next function is the product between a linear function and an exponential function. The guess should be ax plus b times e to the 5x. Right. So you make a guess for the linear function and then multiply with an exponential function. When you have a combination or the product between a power function with an exponential function, so in this case the power function is x squared, when you make a guess x squared, the guess for x squared should be the entire polynomial functions of degree 2. So y sub p is equal to ax squared plus bx plus c times e to the 5x. When you have an exponential functions multiply with sine or cosine functions, then the guess should be a times e to the 3x times cosine of 4x plus b times e to the 3x times sine of 4x. When you have a product between power function and sine or cosine functions, then to make a guess here, what we're going to do is that we're going to write down the entire polynomial function of degree 2 and multiply with cosine and 1 with sine function. So that is ax squared plus bx plus c times cosine of 4x. And we're going to have something similar to this, but multiply with sine of 4x. So this is dx squared plus ex plus f times sine of 4x. For A, B, C, D, E, F are constant or undetermined coefficients and will be determined when you apply the procedure of undetermined coefficients. Okay, so in practice, at least in the example that we are going to have, we're not going to do something like this. This is quite complicated, take a lot of time and effort to find the value of A, B, C, D, E, and F. But this is just to give you an idea how we can apply the undetermined coefficients method to find a particular solution to the non-homogeneous equations. Now for the last case, you have a linear function multiplied with an exponential function multiplied with cosine or sine functions. Then the particular solution is going to look like this. You have ax times b. You have ax plus b times e to the 3x times cosine of 4x plus capital Cx plus d times e to the 3x times sine of 4x. So this is some of the trial solutions that you may encounter, and the trial solutions again has to be based on the forcing terms or G of t, or the right hand side of the non-homogeneous differential equations. Now I'm going to give you the procedure to find the particular solutions of the non-homogeneous equations. Right. So always start with non-homogeneous equation, look at the forcing term. In this case you have a constant multiplied with an exponential functions. Then you make a guess for the particular solution or make the trial solution based on the forcing term. So guess the particular solutions. So the particular solution is going to be of the form capital A times e to the 2t. Again, has to base on the forcing term or the right hand side of the non-homogeneous equations. So for this particular solutions, the assumption is that the particular solutions satisfy the non-homogeneous differential equations. So we're going to substitute y sub p into the differential equation, also the first derivative and the second derivative into the differential equations to help us determine the value of capital A. Then you have y sub p equal to y sub b prime equal to 2a times e to the 2t, and yp double prime equal to 4 times a times e to the 2t. Then we substitute y sub p, yp prime, and yp double prime into the differential equations. We get that. So y double prime is 4a times e to the 2t minus 3 times 2a times e to the 2t minus 4 times a times e to the 2t, and equal to the right hand side, which is 3 times e to the 2t. Now as you see in this resulting equations, you have e to the 2t on both sides of the equations. So e to the 2t here, this here, here, and here. So therefore you can divide both sides for e to the 2t, get rid of it, then you're left with only the undetermined coefficients a. So here you have 4a minus 6a minus 4a equal to 3. That is negative 6a equal to 3, or a is equal to negative 1/2. Therefore, the particular solution is y sub p equal to negative 1/2 times e to the 2t. Again, the naming conventions here is the particular solutions, which is different from the particular solutions where you need to use initial conditions to find the value of the constant. Again, even though they use the same name, they have a different approach, they have a different meaning in different contexts. Now that's one example when the forcing term is an exponential functions. We're going to move on to example 3, where the forcing term is either sine function or cosine function. So for a sine function or cosine functions, the guessing particular solution or the trial solutions should be the linear combinations of both cosine and sine function. So the trial solutions is y sub p equal to a times cosine of t plus b times sine of t. Then you're gonna find first derivative and second derivative, then substitute everything into the differential equations to find the undetermined coefficients. Then y sub b prime is equal to negative a times sine of t plus b times cosine of t. And the second derivative is negative a times cosine of t minus b times sine of t. Then you can substitute y sub p, y sub b prime, and y sub p double prime into the differential equations. We get that. So y double prime is negative a times cosine of t minus b times sine of t minus 3y prime, so minus 3 times negative a times sine of t plus b times cosine of t, then minus 4y, which is minus 4 times a times cosine of t plus b times sine of t, and it is set to equal 2 times sine of t. Now what you do next is that on the left hand side you distribute and then combine like terms. Okay, so I'm going to distribute negative 3 and negative 4 into the parentheses. I got negative a times cosine of t minus b times sine of t plus 3a times sine of t minus 3b times cosine of t minus 4a times cosine of t minus 4b times sine of t equal to 2 times sine of t. Again, we only work with the left-hand side at this point. On the left-hand side, we're going to combine like terms. So combine anything with cosine of t attached to it. So cosine of t here, cosine of t, and cosine of t. So take cosine of t as the common factor, and you're left with the coefficients of negative a minus 3b minus 4a times cosine of t plus anything related to sine of t, right, on the left-hand side only. So take sine of t as the common factor, and you're left with the coefficients of negative b plus 3a minus 4b times sine of t, and this is equal to 2 times sine of t. So simplify the coefficients, and you get negative 5a minus 3b equal to cosine of t times cosine of t plus 3a minus 5b times sine of t, and this is equal to 2 times sine of t. Now, the next step is to match the coefficients on both sides of the equations. Now, take a look at sine of t. On the left-hand side, the coefficient of sine of t is 3a minus 5b. And the coefficient on the right-hand side, where you have the sine of t term, the coefficient is 2. So that's how you match the coefficients on both sides of the equations. Here you have 3a minus 5b equal to 2, because they possess sine of t, or they have sine of t on both sides of the equations. Now for the case of cosine of t, on the left-hand side, yes, you have cosine of t, but you have no cosine of t on the right-hand side. Therefore, you can assume that the coefficients of cosine of t on the right-hand side is going to be equal to 0. Okay. Therefore, negative 5a minus 3b is equal to 0. So that's the next step. So you match the coefficients of sine of t and cosine of t on both sides of the equations. So match the coefficients, and you obtain the system of equations as follows. So negative 5a minus 3b equal to 0. Again, there's no cosine of t term on the right-hand side, so that means we can assume that the coefficient of cosine of t is equal to 0. Now for sine of t, the coefficient is going to be 3a minus 5b equal to 2. Okay. Now you have to follow the procedure to solve this system of linear equations. You can either use substitutions or elimination method to obtain the value of capital A and capital B. So I'm going to leave that to you to do the work. If you do the work correctly, you should get capital A equal to 3 over 17, and capital B is equal to negative 5 over 17. Therefore, the particular solution is of the form. You have y sub p equal to 3 over 17 times cosine of t minus 5 over 17 times sine of t. Alright, so that is the kind of the procedure of undetermined coefficients, where you make a guess on the particular solutions, substitute y sub p, y prime sub p, and y p double prime into the differential equations, and you will arrive as a resultant equations where you can use that to match the coefficients on both sides of the equations to find the value of the undetermined coefficients a and b in this case. Okay, let's move on to another example. So in this example, you have the same left-hand side, right? So the left-hand side is still y double prime minus 3y prime minus 4y, but the forcing term is different in this case. That is negative a times e to the t times cosine of t. So very similar to the last two examples, the first thing you need to do is to make a guess on the particular solutions, or you give the trial solution based on the forcing term here. So the forcing term is the product between exponential function and cosine functions. Therefore, the trial solution is, you have y sub p equal to a times e to the t times cosine of t plus b times e to the t times sine of t. Okay. So you have y sub p. We're going to do yp prime and yp double prime. Substitute everything into the differential equations to help you determine the value of a and b. So yp prime is going to be a times e to the t times cosine of t minus a times e to the t times sine of t. So this result is from the derivative of this product, e to the t times cosine of t. Then you have plus b times e to the t times sine of t plus b times e to the t times cosine of t. Then from here you combine like terms and you get a plus b times e to the t times cosine of t. Here you take e to the t times cosine of t as a common factor, and you take the e to the t times psi of t as a common factor, plus negative a plus b times e to the t times psi of t. So that's just the first derivative. The second derivative is going to be, so take the derivative of this, you have e to the a plus b times e to the t times cosine of t minus a plus b times e to the t times psi of t. So again, these two terms coming from the derivative of the product between e to the t times cosine of t. Now for the next two terms, going to come from the derivative of this product e to the t times sine of t. So that is plus negative a plus b times e to the t times psi of t plus negative a plus b times e to the t times cosine of t. Now we're going to simplify this a little bit. We're going to take e to the t times cosine of t as a common factor and e to the t times sine of t as a common factor to simplify the second derivative a little bit. So you have a plus b minus a plus b times e to the t times cosine of t plus negative a, negative b, so you distribute the negative side here and take e to the t times psi of t as a common factor, minus a plus b times e to the t times psi of t. I'm going to simplify this further, and you get 2b times e to the t times cosine of t plus negative 2a times e to the t times sine of t. Then you're going to substitute y sub p prime, and yp double prime into the differential equation. And this is what you got. Right? So you got y double prime minus 3y prime minus 4y equal to negative 8 times e to the t times cosine of t. So y double prime is 2b times e to the t times cosine of t minus 2a times e to the t times sine of t minus 3y prime, that is minus 3 times a plus b times e to the t times cosine of t plus negative a plus b times e to the t times sine of t. Then you subtract 4 times y, so 4 times a times e to the t times cosine of t plus b times e to the t times sine of t equal to the right hand side, which is negative a times e to the t times cosine of t. Okay. Of course, we're going to distribute, combine like terms, try to simplify the left hand side as much as we can. But the first thing you notice is that every term in the equation has e to the t. So here you have e to the t. You have e to the t here, e to the t here, e to the t, e to the t, and e to the t. And therefore, what you can do is you divide both sides for e to the t, get rid of that, and simplify the problem even further. So I'm going to divide both sides for e to the t. I left with 2b times cosine of t minus 2a times sine of t. Then I distribute the negative 3 into the brackets. I got negative 3 times a plus b times cosine of t plus minus 3 times negative a plus b times sine of t. Then I distribute negative 4 into the parentheses. I get negative 4 times a times cosine of t minus 4b times sine of t equal to negative a times e to the t times cosine of t. Now on the left hand side, again, you combine the like terms. Anything related to cosine of t, you combine them together, or take cosine of t as a common factor. Anything related to sine of t on the left hand side, you combine them together, or take sine of t as a common factor. So when you take cosine of t as the common factor, you're left with 2b minus 3 times a plus b minus 4a times cosine of t. I forgot one thing here, so e to the t is gone, so you're left with just cosine of t. Now, still on the left-hand side, you combine anything related to sine of t together, or take sine of t as a common factor, and you're left with negative 2a minus 3 times negative a plus b minus 4b times sine of t, and this is equal to negative a times cosine of t. Simplify the coefficients even further. That is, you distribute negative 3 into the parenthesis here, and negative 3 into the parenthesis here. So you have 2b minus 3a minus 3b minus 4a times cosine of t plus negative 2a plus 3a minus 3b minus 4b times sine of t equal to negative 8 times cosine of t. Simplifying the coefficients again, you get negative 7a minus b times cosine of t plus a minus 7b times sine of t equal to negative 8 times cosine of t. Alright, so now you match the coefficients on both sides of the equations, and you're going to get negative 7a minus b equal to negative 8 because of the coefficients because you have cosine of t on both sides of the equations, so you match the coefficients of each term. Now you have sine of t on the left-hand side, but there's no sine of t on the right-hand side, so you can match the coefficients, that is a minus 7b equal to 0. So match the coefficients. And we got the following system of equations, that is negative 7a minus b equal to negative 8, and a minus 7b equal to 0. Again, you can use elimination method or substitutions method to solve this system of linear equations. And if you do the problem correctly, you're going to get a equal to 28 over 25, and b is equal to 4 over 25. Then the particular solution is y sub p equal to 28 over 25 times cosine of t plus 4 over 25 times sine of t. Okay, so this is quite long, right? So this is a long problem. It's not difficult, it's just that there's a lot going on, and you have to keep track with all the terms and make sure that you don't make mistake along the way. So be careful when you do this type of problem. In the test, of course, I'm not going to ask you to do something this crazy. It's just an example to see how you utilize the forcing term to come up with the trial solutions, and how would you utilize all the knowledge you learned so far about the first derivative, second derivative, and solving system of linear equations. Try to solve for the undetermined coefficients. Okay. So next, in example 5, we want to find the particular solutions of the non-homogeneous differential equations of the form y double prime minus 3y prime minus 4y equal to 3 times e to the 2t plus 2 times sine of t minus 8 times e to the t times cosine of t. Now we notice that the right-hand side of this non-homogeneous differential equation is similar to the ones given in the previous 3 examples. So that is, we have negative a times e to the t times cosine of t, we have 2 times sine of t, and we have 3 times e to the 2t. So in practice, instead of doing or finding particular solutions for each term on the right-hand side, what you do is that you break it down into 3 different problems. The one problem where you have the left-hand side equal to 3 times e to the 2t. One problem you have the left-hand side equal to 2 times sine of t, and one problem where you have the left-hand side equal to negative a times e to the t times cosine of t. So that you don't have to make a guess that is involved 3 different terms. So in other words, the particular solutions to the given non-homogeneous differential equations in this example is the superposition solutions of those found in the previous examples. So I'm not gonna do the problem in detail. I'm just going to give you the example to illustrate the point that the particular solution in this differential equation is the superposition solutions of those that we found in example 2, 3, and 4. So in the particular solutions, of this differential equations is the superpositions solutions of those found in example 2, 3, and 4. Okay, so instead of solving a problem with complicated right-hand side, is more manageable to solve 3 different smaller problems for that particular solution, then use the principle of superpositions to combine the particular solution. So that's the message I want to send. So note here that instead of solving a problem with a complicated right-hand side or complicated forcing term, it is more manageable to solve 3 different smaller problems for their particular solutions. And then use the principle of superpositions to combine the particular solutions. Okay, so that's just in practice when you have this type of complicated enforcing terms. Is more manageable, but it's more encouraged that you break the forcing term down into smaller part, and then from there you have a different smaller problems to find a particular solution, then use the principle of superpositions to combine the particular solutions together.